Imagine our sun a seething ball of plasma, the nuclear furnace that lights our world. It's the giver of life, but it has a fiery temper. Sometimes a region on its surface explodes in a solar flare, a flash of X-rays and ultraviolet radiation that reaches Earth in just over 8 minutes. This is just the beginning. The sun can also unleash a coronal mass ejection, or CME, a giant cloud of magnetized plasma, billions of tons of solar material hurled into space. When a CME slams into Earth's magnetic shield, our satellites and technology are directly in the line of fire. Our daily lives, phones, GPS, weather forecasts, streaming, global communication all depend on these vulnerable satellites. Out in space, they face the sun's fury with little protection. A truly massive solar storm could cause widespread power outages, crippled communication, and disoriented navigation. The financial and societal costs would be staggering. The sun, our life giver, also holds the power to send us back to a pre-digital age, even if only temporarily. What are solar storms? They start with the sun's magnetic field generated by the churning plasma inside. When these magnetic fields tangle and snap, they release energy as solar flares, bursts of radiation. Often these explosions also launch coronal mass ejections, or CMEs, massive bubbles of plasma shot into space. If a CME is aimed at Earth, it can trigger a geomagnetic storm by disturbing our planet's magnetic field. The solar wind, a constant stream of charged particles, also intensifies during solar activity. Earth's magnetosphere usually shields us, but strong solar events can compress it, transferring energy and causing geomagnetic storms. These storms create beautiful auroras, but also induce powerful electrical currents. The result? Disruption to satellites and technology. Our planet is in a constant battle with the sun's outbursts. The stakes are higher than ever as our reliance on space-based tech grows. Until recently, we worried most about catastrophic satellite failures from big solar storms, but a 2025 study revealed a quieter threat. Even moderate solar activity causes cumulative long-term damage. Researchers analyzed decades of satellite data and found that solar panels and sensitive components degrade faster than expected. Not from single events, but from constant, low-level particle bombardment. It's like a slow rusting process in space. This means satellites may quietly lose efficiency and require earlier replacement, raising costs. The study showed that even during quiet solar periods, satellites are under attack. As we launch more satellites, this hidden vulnerability grows. Our models for satellite lifespan may be too optimistic. The real danger isn't just knockout blows, but a death by 1,000 cuts. This new understanding demands better satellite design and protection. Solar storms have already caused real-world chaos. In February 2022, a minor geomagnetic storm caused dozens of newly launched Starlink satellites to burn up in Earth's atmosphere due to increased atmospheric drag. Even small storms can cost millions. When solar activity heats the upper atmosphere, it expands, increasing drag on satellites in low Earth orbit. If not corrected, satellites spiral down and burn up. Another threat: single event upsets. When a single particle flips a bit in a satellite's electronics, causing glitches or even permanent damage, the impact isn't limited to space. In 1989, a powerful solar storm knocked out the Hydro-Quebec power grid, leaving millions without electricity. Solar storms can induce currents in power lines, overwhelming systems and causing blackouts. These events show how vulnerable our technology is to the sun's outbursts. The risks are real and growing. Solar storms aren't just a problem for engineers, they affect all of us. GPS is vital for aviation, shipping, banking, emergency services, and more. Solar storms disturb the ionosphere, disrupting GPS signals and causing errors that can be critical for navigation and timing. Severe storms can make GPS unreliable or unavailable, with serious safety and economic consequences. Our dependence on space-based tech is exploding as we launch more satellites. Each new satellite is another point of vulnerability. The risk of widespread power blackouts remains, as geomagnetically induced currents can damage transformers and cripple power grids. Recovery from a major blackout could take weeks or months, affecting water, food, communication, and public order. As solar activity rises in the coming years, the threat grows. Understanding and preparing for space weather is a matter of global security. The time to act is now. Humanity isn't waiting for disaster, we're fighting back. Scientists are improving space weather forecasting, using spacecraft like NASA's Solar Dynamics Observatory and Parker Solar Probe to monitor the sun. Early warnings let satellite operators power down systems or adjust orbits, and grid operators can protect equipment. Agencies like NOAA's Space Weather Prediction Center issue alerts to help mitigate damage. Engineers are building more resilient satellites with radiation-hardened electronics and better shielding. Power grids are being upgraded to block harmful currents and stock spare transformers. Global cooperation and investment in research are essential. Public awareness and robust policies will help protect our technological society. The sun gives us life, but we must be prepared for its storms. Our future depends on vigilance, ingenuity, and resilience.